Okay, so had some conversations yesterday with the pre-calc and calc teachers, and they said that worksheet C that I taught you yesterday, that lecture that I couldn't teach. They said that's the least important thing that you'll do all year. They'll never use it again. So you all just got a 4 out of 4 on 10C. Put a 4 on it and put it away. Cool? Eduardo, you going to finish this test with me? Okay.
I will too.
You got one too? And Grant, you got one too? 11A through E? And Cooper, he's not here, but 8G through M. And Cooper has 8G through M, other one. And Grant, you have 9F through K as well. And Peyton has one as well. That's 9F through K.
That's your homework, bro.
I did.
All right. So does anybody have old homework to hand in? If you do, come put it up. I have that meeting Thursday. We don't know yet.
Actually, I'll turn this into tomorrow.
Organized.
Yay.
Wait, do we have to do 10D, E? Do we have to do 10D or E?
10C, you got a 4 out of 4 on just now.
What about
B, I collected. A, I collected. And I will collect D.
you're going to collect D? Are you going to collect E?
No. It's a good thing Kate pays attention in here and knows what we're...
Oh, this stuff.
Durham, I am an overachiever. I did all of this. I'll turn these into all
We
my
use this in
10D.
freaking file. I hated this.
You got it.
And I'll also turn in all of my 12.
You use that?
What did I do wrong to get Kate in class?
Whoa!
Wow.
That was a good high
That
five.
was. I'd give that a 10 out of 10.
11 out of 10.
Even though it's just a 5. Don't worry.
Yeah.
I'm cutting sometimes quick on my...
Thank you.
Sometimes quick and witty.
You got lucky to have me in class.
I feel absolutely honored having you in class. All right, so my friends. So, does everybody understand that 10C, you got a 4 out of 4 on whether you did or not? There's your gimme. Don't ask me for anything else. I'm kidding. Just kidding. Couple of Utes have to do the capstone still. So Angela will take care of you soon. Peyton.
Capstone tomorrow.
Capstone. Parker.
Yeah, I'm doing that.
And then this is for my 8th period just because they might be listening as well. Arjun has it, and Grace has it, and Keith has it, and Max and Muhammad. They all have to do it for my 8th period. That's because I'm recording, All right, my friends.
Watching us from the back.
They are. Or from the front. They got front with me. Review, we're not going to do it. So my plan, my friends, for from here till the end, so I'll lecture this, then we'll go over these questions tomorrow. If you have any questions on 10D, it'll be odds. So those of you who sit there and work on homework during class, go for it. Let's see. Today's Tuesday, right?
Yeah.
Okay, thank you. I'm losing days. My mind's already been gone, so I guess I can lose days. So tomorrow, which is Wednesday, Thursday, and Friday, I'm just covering questions on anything on that review. And I will record both this period and 8th period.
On Thursday?
So that would be Wednesday, Thursday, Friday. So I'll record both this period and 8th period just in case there's some questions asked in this period and not asked in 8th period or vice versa. Cool? But I think that everything in that review, I think it's pretty good. And then which final is this for us? Is this the very last one?
Yeah.
Last day, the Thursday?
Mm-hmm.
But the first one Thursday?
Yeah.
Okay, cool. So, I still have not met with the CP Algebra 2 team. I'll meet on Thursday to find out if we're dumping a quiz score. I don't know yet. It doesn't bother me if I do or don't, but
I don't know what the problem would be.
I think you guys should dump the quiz.
please do. You have a 98? What?
No, 90.
90. Oh.
90. That's the worst.
Olivia, did you see what your grade is now?
I know.
I know. I told you you would kick, you know what, on that?
Yeah.
A 35 out of 36?
I'm surprised it like brought my grade up so much.
It was counted as a 0.
Well, yeah, but it's only like a 36.
Okay, no, but
I know.
anything out of
But it like totally brought you up.
like grade down like hell.
Huh? Brought you up.
Well, now I have to.
I thought 0 was the huge.
So the nice thing is, if I drop a quiz score, that one doesn't get dropped.
I can still get this curve.
The one. Okay, because the only reason my grade is like not like a 92 is because I got a D on my test.
Oh, I'm sorry. I'll go back and regrade it. I probably made an error.
No, it's
I probably was grading the algebra. I had the algebra 1 key next to the algebra 2.
You have the history
Will
textbook
you
open.
drop it before the final so we can see what we have?
I don't know yet. I'll find out Thursday. Thursday when we get to this class,
Why do you have to have everyone else? Like, why do you have to have everyone?
because you all talk to your friends and other teachers and other teachers, and then your friends go and complain saying, but Mr. Stirrup did, and then all the rest of the people are like, I'm so sick and tired of hearing what Mr. Stirrup did.
Stir up the pot.
Need to be as good as you.
Oh no. I'm somewhere in the middle percentile as far as the math teachers
We're
go.
on a whole different track.
No, you're just saying that because you're waiting for the grade to hear. That all changes next
I
year.
don't have that. I have like a B in the
I mean, Sam has 2 math teachers right now. I'm sure he says Miss Schumann Smith is a much better math teacher than
Sam, who's
I
a better math teacher?
I mean, it's hard to decide, but Stirrup's a really chill guy.
am. He sucks at teaching, but
Alright.
he must be a mushroom. He's a fun guy.
What's the last day we're doing that with?
I would say Thursday of our final.
Okay.
That gives you something to do while you guys are doing your final. I don't. Here, actually, you blow it on the Kansas City flag.
Oh, perfect.
All right. Are you ready for the last lecture for today?
Are you ready to rumble?
Okay, so starting tomorrow, make sure you have brought your review with you, please. Okay, it's the very last pages of the chapter. Cool. So if you're that person who's printing them off, print off the semester review. It's at the very end of the chapter on Schoology. All right. We are going to develop a understanding of summation notation and the sums of series. All right. So here's a classic question. So I started the school year. Remember, I had riddles. You guys thought I was like the best teacher in the world because I had these riddles. And then like we went for 8 months without them. Well, here's your last riddle. All right. If I were to add all the numbers from 1, 2, 3, all the way up to 1,000, what do I get?
Wait, what?
If I add all the numbers from 1 to 1,000 up, what do I get? A big number, yeah. It's more than 1,000.
10,000. 2,000.
Wait, what?
It'd be 1,099. I mean, 999.
Okay, let me ask you this.
500,500.
Oh, you know the trick?
No, I
No.
looked it up.
Oh, you looked it up.
Yeah.
Oh. Here's the trick if you don't have Google. Okay, so if I add the very last number and the very first number together, what do I get?
1,001.
1,001. Now, if I added the second number and the second to the last number, what would I get?
1,021.
And if I added the third number and the third to the last number? 1,001, 1,001, 1,001. So how many pairs of numbers are between 0 or 1 and 1,000? And that would be 500.
What? Pair. Oh.
There's your answer.
Wow.
Boom!
Wait, how did you get 500?
There's 500 pairs of numbers because you have 1,001. There's one pair.
Interesting.
999 and 2. There's another pair. 9998 and 3.
We do one more.
Yeah.
All right. You want to sum up between 0 and 10,000. So that's 10,001 times 500. 0, 0, 5, 0, 0, 0. 5,500,000.
Wow.
If you wanted to do just between 1 and 100,
500.
so that's a 101 times 50, so that's 50-50. 50-50. That's a great skateboard trick when you're riding half pipe. Anyone know what 50-50 is?
No.
Oh, you don't? This is where you come up on the coping. That's the rounding. I used to skate. But a 50-50 is a great trick where
Wait, do you have a skate story?
when you're on a half pipe,
Shred on the top.
and what you do is you get onto your axles and you shred, you just grind all the way down, and then you drop back in. And you do a front side or back side.
Do you
Yeah.
have a hippie phase?
Hippie face? No.
No, you had to do a skater boy face.
I did have a skater face. Yeah, I skated. Well, we always skateboarded, but then we got serious into skateboarding. 7th, 8th, 9th, and 10th grade.
Wait,
Oh my
did you
God,
have
Wait, stop. Do you have a good story from it?
You remember the half pipe in the orange story, or the orange story?
Yeah.
Bobby Duenas and I hid under Shane Beaujolais' half pipe. Yeah,
Yes.
yeah, we built half pipes. We
Nice.
built.
How'd you do that? Do one.
Yeah.
A new skate story.
Was it just Avril Lavigne and Blink-182?
Yeah,
Yeah.
you have to have a skate story if you skated. That was like a solid time.
You
too.
hit your friend in the
What's
head with
your
a
best
skateboard, you smacked your head with a skateboard, something.
All right,
You stole a cop's donut?
I stole a cop's donut.
That one didn't make much sense.
Hope not.
Normally, somewhere sense. That one just didn't really make much sense.
No, you know how cops have donuts.
So,
Skate by and take the donut.
so back in our days of skating, so the first ramp we built was Shane Beaujolais' ramp. Then we built Zach Pace's ramp at his dad's house. Then we built Zach Pace's ramp at his mom's house. And the one at his mom's house was awesome. It was 24 feet wide, had a roll in, and had 2 gravestones. The gravestones where you go, above the vert a foot or two.
Ooh.
And I tell you what, when you drop in on that gravestone at true vert, you can catch some major air on the other side. I can't say you always land it.
Catch some air.
Catch some air.
Stuff.
So Zach's, and then we built Mark Jones's ramp. Mark Jones's ramp was frightening because it was 14 foot high, and you had 13-foot transitions, which meant the last foot was vert. And you got on top of Mark Jones's ramp. Mark Jones's dad was like this contractor, so he had all the best wood, and we had total masonite on it, so it was totally slick. You get up on there, and you're sitting there, and you go to put your foot and drop in. You fell for a while. It was like, whoa! And you went. It was fun. Chuck Adams had a great ramp. Chuck Adams, it was funny. We built this ramp right behind his stables in his backyard. And so his horses would sit there and be eating all around us in the pasture, and we had this half pipe we built. One time at Chuck Adams, a guy named Alan Midget came over, and Alan Midget was sponsored by Alpha Skateboards, and he said, "Hey, can I bring a couple buddies tomorrow?" And he brought a couple buddies. He brought a guy named Jeff Phillips, who was sponsored by Sims. He brought a guy named Lester Kasai, who was sponsored by Sims, and he brought.
How do you remember who was sponsored by?
Because we had all the boards.
Oh.
You have like a really good memory.
Yeah.
Very good.
Yeah.
Well, I can't remember our anniversary. That's why I have it engraved on the inside of my ring.
Wait, that's so cute.
So guys, when you get married, engrave, and your wife would think it's all romantic, but just make sure you don't get fat after you get married so you can get your ring off so you can look at the date. And you can also set the calendar on your phones.
Nice.
Let's see. We went one time, there was this real spoiled kid. I don't remember what his name, but his mom's name was Patty Sellers. She had an amazing ramp out in Scottsdale. And we went there one time, and Steve Caballero and Tony Hawk were skating. That was pretty sweet. I did not have the guts to drop in when Tony Hawk was standing up on top with us.
Why not?
Yeah, he's like the best skater in the world.
You could have done that. You could have
I
done
remember.
I saw Tony Hawk do. This was back in the mid '80s, so I saw Tony Hawk do. I saw him do a 720 on his third time, and now he's doing a 1080. Or, I don't know if he's doing it, but that was
He's
pretty
still
cool.
skating.
Yeah,
It's crazy.
but I'll tell you what, when you're standing up on the platform, and Tony Hawk comes up and he's this high up, and he twists 2 full times and drops back, you're like, it's like, this is amazing. Steve Caballero used to catch 12 to 13 foot air over the top of the ramp. So you'd be standing there, you're like, whoa! you're like, how does he have the guts to go that high?
Yeah.
That was good stuff.
If you fell off up there, man, that'd be deadly.
Yeah, they used to skate with double knee pads.
You ever see people downhill longboard?
Yeah,
It's crazy.
that is crazy. All right, moving on. Let's teach. Finite sequence. Finite sequence, infinite sequence, finite. So finite means it ends. And then you have sequences and series. So a finite sequence, this would be a finite sequence. It ends. Okay? Okay, so finite means it ends. If I want an infinite sequence, it is this one. Now, what's the difference between series and sequence? Series means we're adding things together. So I have a finite series because it ends, and I have an infinite series because it doesn't end. Oh, that was tough stuff. So difference between sequences and series you add or subtract. Cool? Good so far? All right. Now we're going to get into the Greek number system. Do you need me to go back? Sorry. No, I guess that was just a yawn. All right. So now we're going to start learning Greek. Okay, that's the Greek letter sigma. And the math, it stands for summation. Summation means you're just adding a bunch of stuff up. Okay? So when we write the Greek letter sigma, we start with our lower bound at the bottom of it and our upper bound at the top. The upper bound can also be infinity. The lower bound can be 0. It can be any number you want. So what we do with this is just say, hey, see if you can catch what I'm doing. 3 plus 6 plus 9 plus 12 plus 15. What did I just do? What? I plugged 1, 2, 3, 4, 5 into I. I is not acting as imaginary, it's acting as a variable. And then we add things up. So that's 18, that's 30, and that's 45. We good? Does all seem to make sense so far? Is anybody stuck? Almost done. Well, not really. All right. What do you think we do on this one? Hey, so why did I switch to n? Because we just switched variables. That's the only reason. There's no other reason. We switched what the variable was. All right, so that's -2 plus. If I plug 2 in, I get 4. That's 1 plus. If I plug 3 in, I get 9, which is 6. If I plug 4 in, I get 16, which is 13. And if I plug 5 in, I get 25 minus, that's 22, right? All right. So I'm plugging in 1, 2, 3, 4, 5 and doing the arithmetic. Okay? -2 plus 1 is -1. -1 plus 6 is 5. 5 and 13 is 18. 18 and 22 is 40. Yes. Life is good so far, I think. Yep. All right. Hey, may I move on?
Yes.
Yep.
All right. So then we want to say use some summation notation for the series. So we have to figure out what equation we're using. So I can tell you this. We're going to have to pick a variable. It doesn't matter. So I'll say x equals 1. And we're plugging in 1, 2, 3, 4, 5, 6 things. So I'm doing the summation from 1 to 6. And then the equation that works. The equation that works on this. Let's see. I have a common difference of 5. Right? So I know that my equation is a equals a sub 1 plus n minus 1 times d. Right? That's our general equation. This equation will be given to you on the final. There's like a page. All right? And so I know my first term is what?
7.
7. And my common difference is what? 5. Okay, and then we could say, I guess we could clean this up a little bit. I'll do the math for you. A sub n equals 2 plus 5n. Is that right? So then that means that I'm going to plug 2 plus 5n right here. And then if we wanted to know what this equals, if we truly wanted to add it up. So technically, use summation notation. This would be the completed form. If I wanted to add it up, I'd add 7 to 12, that's 19. 19 to 17 is 36. 36 to 22 is 58. 58 to 27, 65. 85. 85 to 32. Oh, I just lost it. Fell out of my head. You guys can add that up. How do we add it up? Well, use a calculator.
What's addition?
What's addition? All right. Hey, what's my common difference on this one? Negative what? Negative 8. All right. So again, I'm going to use my equation here. So let's see. I got 1, 2, 3, 4, 5. Hey, but it's infinite. What do I put on my top bound? Infinity. So I go the summation, and we'll say j equals 1 all the way to infinity. Hey, why does it go to infinity? Because it's dot, dot, dot. All right, so I have a sub n is equal to a sub 1 plus n minus 1 times d. My first term is what? 50 plus n minus 1 common difference is what? Negative 8. Distribute the negative 8 because it looks a little neater. Minus 8n plus 8. So a sub n is equal to 58 minus 8n. Hey, let me ask you this. If I were to sum up an infinite amount of numbers, what number do you think I would get to?
Infinity?
Infinity, yeah. Yeah, here's your answer. Why did I choose J? I don't know, I'm just picking variables. Am I going too quickly for anybody? Is anybody lost?
No.
Hi. Can I move on? All right, it says, how do we find the summation of a finite arithmetic series? So, I'm going to plug 1 to 14 all the way in. Agreed? So that's going to give me like 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21 plus 23 plus 25 plus 27 plus 29 plus 31. And if you add these all up, you find you get 252. So S at n refers to the sum of the first n terms. So that's what this is. S at n is equal to that. So when you see S at n, that means the summation of your series. Am I going too quickly?
No.
Everybody happy?
No.
I'm sad. I can't see, sorry. Ready, Freddie?
Yeah. Thanks.
All right, so there has to be a better way to do these kind of equations rather than just plug them all in and add up, because if we did the summation of I equals 1 to 46,000, that's an awful lot of, don't talk to me, 1 plus 7 plus 15 plus, right?
Yep.
And you're like, what number I was on? I don't remember. I think you said 36, but it might be 39. Okay? So in general, the sum, S at n, of the arithmetic series would then mean S at n equals a sub 1 plus a sub 1 plus d plus a sub 1 plus 2d plus a sub 1 all the way to a sub n. Which also is the same thing as S at n. So if we go through all of these, if we go through all of the iterations of this, if I were to take this whole thing, watch what would cancel. I have positive d, negative d. Still with me? I have positive 2d, negative 2d. Still with me?
Yep.
Okay, so all of the d's all the way down are going to cancel out. And so that's going to give me this general equation. So some people prefer it to be like this. Okay, both equations mean the same thing. Hey, what is a sub 1?
1.
No, what's a sub 1, just in general, on any series? It's the first term. And if it's finite, it means we have an ending term, so what's a sub n? Last term. All right, so let's write that. So this would be our first term, and this is our last term, which means if you had the summation, you'd have to plug your very first term in and get that answer, and then you'd have to take whatever your upper limit is and plug it in and get that term. You don't have to add them all up, but what does n mean? What does n mean? Number of terms. And what does 2 mean? It's just the number 2. All right, so
2 means 4.
So that's the equation. Next slide shows the exact same thing. That's our general equation. I know that will be on the final exam, and it will be a formula you can find. It's given to you. You just have to know what things mean. So in words, S at n means is the mean or the average of the first and the nth term multiplied by the number of terms and then divided by 2. Okay, that's all that's taking place. So you're just taking the average. Okay? Can I move on? Anything there? Anything else on this slide that we need to worry about? Nope. All right. So, if we wanted to find S12, so I'm going to do this. From n equals 1 to 12 of -3 plus 4 n minus 1. How do I find the first term? How do I find the first term? A sub 1. How do I find a sub 1? Plug it in. So I plug 1 in there. 1 minus 1 is 0 times 4, 0. -3 plus 0. -3. What is my nth term? So my nth term is going to be my 12th term. Why is it my 12th term? Because 12 is my last region. Okay? So let's plug 12 in. 12 minus 1, 11. 11 times 4, 44. 44 minus 3, 41. Okay? Waiting. We good? All right, so then we want to find S at n, which we just said was n a1 plus an over 2. So how many terms are we plugging in? Well, 1 to 12, that's 12. First term is -3. Last term is 41 over 2. Okay. Some of us might remember Algebra 1. That can go in there 6 times, so we can reduce if we need to. -3 added to 41, I believe, is 38. So I get 6 times 38. Am I good with that math? And then 6 times 38, I don't know. So 6 times 8 is 48. Carry the 4. 18, 228. So if I were to have the equation -3 plus 4 quantity n minus 1, and I wanted to add up the first 12 terms, they would add up to 228. Now, could you have done that maybe faster on a calculator? Possible. But if I change that upper to something bigger, then you're going to start losing what your calculator can do. Yeah.
Okay, wait.
Waiting.
How did you get A1?
All I did is I plugged 1 in. So this is going to get me A1. So I plug 1 in here. 1 minus 1 is 0. 0 times 4 is 0. -3
And
plus.
41.
I plug 12 in. 12 minus 11, or 12 minus 1 is 11. 44 minus 3, 41.
So you put 12 in for n and 41.
I understand.
And then I have this right here. That 12 goes right there. So people say, well, that's also the upper bound. Don't always assume it's just your upper bound. You still okay?
Yeah, we're good.
Oh, look, Cupcake and Sunshine showed up.
No, we got 1 Happy Meal for our marketing project. With no food in it.
That happens. All right. Can I move on? Ready? So find the summation of the first 6 of a geometric series. So geometric's different than arithmetic, right? So this would mean I'm going to plug 1, 2, 3, 4, 5, and 6 into this. So if I plug 1 in, that's an exponent, n minus 1. So that's 0. 4 to the 0 is 1. So that gives me 10. And we're going to add all these up. And then I plug 2 in. 2 minus 1 is 1 times 4. So I get 40. Plug 3 in. That gives me 160. Plug 4 in. So that's 64 times 10 is 640. Plug 5 in. Uh-oh. I can't do it in my head anymore. 2560. Plug 6 in. I get 10,240. And if you're like a really bad person and you like to add stuff up, you come up with 13,650 is the, I don't know why I have a number sign there. 13,650 is the summation of the first 6 terms. Okay, geometric, you're probably going to run out of room real quick in your head and on your fingers when you plug it into your calculator. So I would bet you that there is also the sum of the first n terms of a geometric series. And we know it's geometric because we have a common ratio of 4. So, almost done, almost done. Let me finish. Let me finish. All right. So, the equation for geometric, and this is finite geometric because it ends. So we have the first term is a sub 1, and then I have 1 minus r. R is the common ratio, right? And we raise r to the nth power. So that's your end result. And then you have 1 over 1 minus r. So we're going to go to that equation. So let's do this one.
Wait, what was the last one? What's this? What's the difference?
This is geometric because you're multiplying as a common ratio. Arithmetic. Because you're adding.
Huh, look what I did.
I don't know.
Turned in D. And then you gotta turn in that.
You're doing
Actually, I
it.
won't be here tomorrow, so.
Yes, you will.
Nah, dude, I got the AP Lang test.
Okay. I'll record for you.
Thanks.
Yeah, buddy. All right. So let's use our equation. I know that this is my geometric equation. That's r to the n. Okay. So let's figure this out. We want to do the summation from n equals 1 to 5 of 81 times 2/3 n minus 1. This would be kind of nasty to do by hand. So let's figure out what we want. We want to figure out what A1 is. So that means I'm plugging 1 in. 1 minus 1 is 0. 2/3 of the 0 is 1. 1 times 81, 81. We have our first term. Hey, what's my common ratio up there? So my ratio is equal to 2/3. And then r to the n. R to the n. Not negative 1. What's my top limit? 5? You good with that?
Why?
It's my top limit. It's my nth term. My last term. Nth. All right, plug it in. Summation of n equals 81. I'm almost done. 1 minus 2/3, excuse me. Anybody have a calculator out? Cool.
That looks complicated.
All right. 81, plug it in your calculator. 1 minus 2/3 in parentheses, raised to the 5th, close parentheses, divided by parentheses 1 minus 2/3. And if you do this math correctly, you come up with 211. I would definitely use a calculator on this one.
Are we going to be allowed to use a calculator on the final?
Some. All right, am I done yet? Almost?
How many questions on the final itself? 660.
Sounds good. All right. Some summations of infinite geometric series can be found. So this is basically going 1/2 plus 1 plus 2 plus, keeps going, 3/2, something like that. So, wait, I'm on the wrong page. summations of infinite series. Oh. I don't know. This doesn't have an agreement, so this one can't even be done. All right, so if you have the summation of an infinite geometric series, you're going to have your first term over 1 minus your ratio. Okay? So if r is less than 1, so if r is less than 1, good. If the absolute value of r is greater than 1, the series has no sum. So if this is like a 7, then it doesn't have a sum to it. So let's go through this. Find the sum if possible. So just to save time, we have a ratio here of 1/5. So if I want to do the summation of that, of the infinite term, I have my first term over 1 minus r. So my first term is -5. 1 minus r, 1 minus my ratio. You do the arithmetic here, you're going to find that this would sum to -6.25. And then this one, if you wanted to find it, this is actually a sub 1. Okay, the reason you know that is if you plug, you're plugging 0 in, but it's my first term. So then I'm going to do the summation of the infinite. This is my ratio. So I'm going to get 1/12 over 1 minus 3 over 25. And if you do this arithmetic here, 1 minus, that's a negative. There's a minus there like that. I'm sorry. So if I do this, I come up with 25 over 336. And that's how I teach Algebra 2. Accelerated. Done.
Stir up.
Thank you.
Coming in at 8.
We good?